Hi, I'm Daniela and I'm about to graduate high school. I'm planning to study biochemistry, the science that uncovers how living things work on the molecular level. But today I'm not talking about cells and molecules. I'm talking about how biochemistry can be used to help solve one of the world's biggest problems: how to grow food in extreme conditions on a planet facing both climate change and a growing population.
Here's the reality. There are over 8 billion people on Earth and 800 million suffer from malnutrition. By 2050, the world's population will hit 10 billion and will need to produce 50% more food to feed everyone. Droughts, heat waves and extreme weather are already affecting crop yield, with Canadian farmers already seeing significant losses due to changing conditions such as wildfires and floods. That's where the science comes in. With biochemistry, we can engineer crops that withstand harsh conditions. By understanding plant physiology at the molecular level, we can improve plants to handle heat, drought, and unpredictable weather, making them more resilient. For Canada's agriculture sector, this could mean better, more sustainable crops that are climate resistant, improving both yields and food security. That is exactly why I'm passionate about biochemistry. By studying it, I'm not just learning about molecules, I'm learning how to use them to make real-world change. As climate change continues defying agriculture, it's our responsibility to innovate, and with the right science, we can revolutionize how we grow food. Humans started the domestication of crops around 9,000 years ago by selecting for desirable characteristics. Plant breeding has saved millions from starvation. However, this traditional approach is reaching a plateau. Knowledge derived from biochemistry is now used for molecular breeding, which makes use of viral molecules to engineer crops with targeted, improved characteristics. This is especially crucial for Canada's harsh agricultural conditions. Potatoes resistant to viruses, soybean and corn resistant to insects, beets resistant to herbicides, apples that don't turn brown, crops with enhanced growth rate, and even wine produced by improved strains of yeast are some of the foods currently approved for consumption in Canada thanks to an understanding of the biochemistry of these organisms. Unraveling plant physiology through biochemistry to understand the way plants function can support new technologies, enabling us to breed plants that can adapt more efficiently to extreme conditions.
As a future biochemist, I'm excited about the potential of improving crops and food processing to help Canadian farmers adapt to climate change. By understanding plant physiology and using biochemical insights, we can develop new breeding technologies to guarantee that food remains accessible and affordable for all, ensuring that Canadian farmers thrive even as climate extremes become more frequent.
Through biochemistry, we can support food production, helping to secure the future of farming. This is the future of agriculture, and I'm excited